Hello, everyone, and welcome to the webinar. This is Sydney speaking, and in today's webinar, we'll be showing you the new options in SolidCAM 2019, basically in 2.5D milling and general enhancements and some of the things that we've showed also in iMachining as well. Now, a few things before we get actually started. In our website, I will have this webinar. I am recording this webinar, and it will be available in our website as we go along. If you go to our website, you'll be able to see that we have a webinars tab, www.solidcam.com, and in the webinars tab, we have webinars recording. This webinar is being recorded, as I said, and will be available later on at this point. Okay, so let's get started. Okay. Let's first get started with some of the new enhancements we have in SolidCAM in 2019 in 2.5D milling. One of the new options that we have, this is actually a new operation, it's called multi-depth drilling. Now, multi-depth drilling gives you full control of your drilling operations at every single depth, and this is extremely useful for deep holes and also drilling through cross holes. Now, we give you full control of your spin and drill direction, your spin feed and your drill direction at every single point, at every single segment. And also, it's extremely helpful, like I said, for deep holes, for also retracting as well. So every single point, you have complete control. And obviously, I'll be showing you this on the actual part. You can also control your spin rate, your feed rate at every single segment, and you also have complete control of your pecking, whether in your pecking data. You can also do the pecking data with step downs and incremental or decremental step downs as you go along. You can also retract, whether you want to have a full retract or go to the start of the segment, or just a user-defined retract. All this is available inside the multi-depth drill data. Okay, so let's get started, and actually let's take a look at it. Now, as we go along in the webinar, I'll also mention some other things, such as changes in our interface. One which you can see right now, in fact, is the fact that we have in the task pane on the side in SolidWorks, you see that we have also a tab for SolidCAM itself. So instead of going to right-click on Tools or Tools and then go into SolidCAM to get to what you need, you can go directly over here, making it a lot easier to get actually started. Your recent parts are here as well. Okay, so let's go and open up a specific part. And let's start with multi-step drilling. Now, I'm going to actually show this option on two different parts. The first part that I'm going to show you, I've actually already programmed it. I'll show you how it looks with the interface itself and explain more or less what I did. And in the second part, we're actually going to program it for you. Okay, so as you can see in this particular part, we have some holes going through. Let's take a section view of this. You can see we have these holes going through to the bottom of the part, and we have a cross hole going through at specific points. Now, what many people would like to do in these particular cases is drill down up until this point, continue with a rapid or a faster rate down here, and then start pecking maybe again over here. Again, go down, and the same thing with that hole, and then go over to the next hole. So let's take a look at the operation. As you can see on top over here in the ribbon, we have the multi-depth drilling operation. Now let's take a look at the actual operation that I created. The start looks exactly just like any other drilling operation. Choosing your geometry, your drill, your tool, your levels you'll see the actual upper level and the actual final depth. And if you want to have the full diameter of the tool going down to the bottom, that's what's defined over here. Now, when we go into technology, that's where you're given complete control. And I'll explain exactly what I did over here as we go through the part. What you'll see here is as follows. We have all the different segments. Adding a segment, you can just click on a add or delete an existing. As default, you'll always get the safety distance to start off with and the final depth. And all of these are segments that I added in. Now, what did I do here in the segments? When I first started, I decided, you know what, I'm going to go to my first location, 2 millimeters above the part, to my safety distance, and at a specific feed that I decided I wanted to work at, but I have my spin direction as off. Okay, whether it be for whatever reason I may want to do that, and I'll talk about that in a few moments. I have my coolant turned off, no dwelling needed over here. Now, in my second segment, I want to go down to just past this point over here. So I'm going down to minus 33, and I decided I wanted a feed rate of 600 millimeters, the spin rate that I wanted. I'm going clockwise, and as you can see here, I can change this to any direction I really want. If I want to even go counterclockwise, but we don't need that for now. I turned on my coolant, and I'm using my dwell time, which is down here at the bottom. Now, in addition to that, you'll note that when I'm at this point, I'm using my PEC. So I'm going to have a step down of every 4 millimeters, and I'm going to have a decrement of 1 millimeter, and my minimum of 1 millimeter as well, which that means it's very simple. If I start at 4 millimeters, then I'll be doing my next step down is 3, then 2, then 1, and it'll stay at 1 because that's my minimum. Now, my release distance, I'm going to go up to a PEC clearance level. In other words, I'm just going to go up 1 millimeter every single time, and when I go back down, it's going to go 0.1 millimeters before it starts actual drilling again. Now, my next segment is this area over here where I have no hole. So I decided to go a lot faster there, kept the spin rate. I decided to keep my coolant on, no dwell time, and you'll see in this particular segment, my PEC is off. Now going to the next level, minus 83. Same thing I did in the first thing. In the first segment number 5, going all the way down to 120. To up until this point over here, and then going down to a 153, again having my PEC on, okay? And then when I went back up, just to show you I can do it, I went up to minus 3 millimeters, and I decided to go counterclockwise for whatever reason I may want. And then when I went from 3 back to 2, I decided, you know what, I don't need a spin at this point. Now, this sometimes is very, very helpful. And especially when you have long tools, and we'll see that in my next part that I'm going to show you. Because sometimes with a long drill, when you're outside of the material, it starts flying all over the place. So before you exit, you may want to sometimes turn off the actual spin. Okay, let's take a look at the actual simulation. And we'll do this one step at a time. You'll see that the tool started coming over here. And if you take a look at my simulation data, you can see that my spin is off. If I go to my next step, now it's going down to 2 millimeters. My spin is still off. And now it's starting to go down to minus 2. And you can see how the pecking is working. As it goes down, it's going to go down to the next step till it gets to that hole. Once it gets to the hole, it's going to go down to this step, and then it continued on here, and then the same thing until it gets to the very bottom. Same thing over here, that step, that step, that step, and then finishes the part. Now I'm going to load another part, and in this part we're going to actually program it. So you can see exactly how the programming works. So if I open the next part, and we're going to make this a relatively short program over here. What I'd like to do is I'd like to drill out these two holes. Taking a look at the section view, you can see that they're relatively pretty deep holes. Okay, they're about 250 millimeters deep, and the diameter of these holes is 6 millimeters. Okay, so what I decided to do is I created already two regular drilling operations, one doing a regular spot drill, and my next one using a regular drill to go down as deep as I possibly can with a regular drill. Okay, in this particular case, it went down to 100 millimeters. Now I want to start my next operation of multi-depth drilling. We'll click on that. I'm going to use the same geometry I used before. To choose my tool, I'll select, excuse me, I'll select my 6 millimeter drill, which is outside of its holder by 275 millimeters. So I have enough outside the hole, but you can see it's actually a pretty long drill. In my levels, I'll have it from 0 to 250. I want the full diameter of the tool to go outside of the part, and I'll even give it a little bit of a delta of -1 millimeter. Now we go into our technology. As you can see, as default, we have our safety level as our upper level, as our first segment, and my final depth as the next segment. Now, for my first step, I want to actually have this go at, say, even rapid. I'm going to have this go at rapid. So I'm just going to put it at rapid, outside of the material. My spin, since it's a long drill, I don't want to have the spin start yet. So I'm going to turn that off, as well as my dwell, don't need that, and I do not need my coolant at this point. Okay. Up until this point, we're fine. Next, I'd like to add another segment. So I'm going to go to my plus over here, or I can also right-click to add. And in this step, I'm going to go down to -5. Okay? I'm going to have it at 300, but I'm still going to keep my spin direction at off. Why? Because I don't want it to start spinning outside of the material. I'll keep my coolant off as well. And at this point, obviously, I still do not need my dwell time. Now we're going to go to our next segment. I want to go actually all the way to the very bottom already. I'm going to have that feed rate I have over here, my spin rate. I'm going to leave it at at clockwise. Okay, have my coolant on and have it dwell at the bottom of each step. I'm going to turn on my PEC for this particular step. Sorry, for this, not this one over here. That one to turn back off. But for this one over here, I'm going to turn on the PEC as shown over here. I'm going to have it go down for 6 millimeters and then decrement for 0.5 millimeters up until I get to 1 millimeter. In other words, it's going to go from 6, 5.5, 5, 4.5, so on and so forth until it reaches a minimum of 1 millimeter. And my PEC clip, I want to have not a full retract, but I'd like to have a retract at every single point, just a user-defined clearance level. I'm going to go up just 2 millimeters, and then when I go back down, I'm going to go back down to 0.1 millimeter. Now, at this point, I want to add another segment. Going back up, I'm going to go back up to -5. Okay? One more step I forgot to do. There are people that since I went down I'm already drilled down to 100 millimeters, I can say, you know what? Let's go back to this point and add one more step. And at this step, I'm going to have it go to -100. I'll go a little quicker because I'm not drilling anything yet. Okay, spin rate. If I want to go, and I know people in this particular case sometimes like to prefer going counterclockwise, so they don't want to cut as they're going down. Okay. And obviously, in this particular case, I don't need any dwell. I may leave the coolant on, and I do not need any kind of pecking at this point. Okay. Now going back to -5, we have this over here. And when I'm adding my last point too, I'm going to just turn off my spin rate. And I'll turn it off. No coolant. Turn that off. No dwell. So the idea behind this entire operation, it's giving the user complete control of every single segment inside this particular drilling operation, which is very crucial when you want to do deep drilling or through hole drilling. Let's just calculate what I've done over here. And if we take a look at our simulation, and I'll do this one step at a time, you'll see we will start drilling. Now I went down to that 100 millimeter point, and now it's going to continue drilling down until it gets to the very bottom of the part itself. Okay, as we can see, it goes now. It's going every 1 millimeter, as it started every 6 millimeters in the 6 millimeters at the very beginning. When it finishes that, it's going to go back up. I'm doing this now one step at a time to show you what's actually going to happen now. It went back up to -5. You can see now at 2 millimeters, my spin rate is off. And now it's going to go to my next hole and do the same thing over there. So that is the option of multi-depth drilling. Okay, next. Now, I just want to do a little review of something that we've added in 2018. Many of you may have not seen this yet, or may have not had a chance to use this yet. So I'd just like to go over it, because this is a very powerful part inside our program now. And this is called drag and drop templates to model. Now, you can actually take now your templates that you may have from the task pane that we have on the right side and drag it to any of the faces of the part to create an operation. This works extremely well in iMachining 2D, iMachining 3D, HSM, HSS, pocket operations as well, and pocket and chamfer recognition also. All of these can be dragged to the part to create the tool path. Now, these templates can also be dragged not just to the face itself, but can also be dragged to the CAM part manager. And if you drag it on an existing geometry, it'll also create the operation. If you drag it to the CAM tree, it'll create the operation, but then obviously you'll have to add your geometry to it. Now, one other thing that's extremely nice is that you can also drag and drop an existing operation to the part. So if I have an operation that just created without templates, I can actually take that operation, and if I want it on a different area, just drag the operation to the face of the part, and you'll get the other operation in there as well. One more note is that in drag and drop, when we save our drag and drop, we can also capture our geometry filters. And in a moment, you'll see what I'm talking about. So let's go back into SolidCAM, and we'll load our next part. Okay. As you see, we have this part over here, and I have my list of templates over here. Now, if I have a big list and I don't want to, if I want to actually filter them out, I can just type in over here what technology I'm talking about, for example. For instance, if I want to see my face mills, just start typing and you'll see it actually filters out. So what I'd like to do first, I'd like to put a face mill operation on the top of the part. To do that, I'll take one of my face mill templates. In this particular case, I'll take this one, just drag it to the part, and you'll see that it'll create right at that point the face mill operation. You can see that here as well. Want to create another operation, such as another, let's say, an eye machining operation inside this on this surface over here. So let's go down to eye machining, and I'm going to take this one that I have over here, drag it to this face, and it'll calculate the tool pass. Oops, sorry, I took my face mill instead. Just delete that. And like I said, I wanted my eye machining. So here we go. Eye machining. I'm going to take this one over here, drag it to the face. And as you can see, being calculated, and you can see the tool pass created on those areas over there on this entire face. If I want to do it to this face over here, and all of these faces, I want to have that in one operation, I can drag it to this face over here. Before I let go of my mouse, I just hold my control button and then just click on every single one of those surfaces. When I let go of my control button, you'll see that every single one of those surfaces has a tool pass added on it. Very simple to use, very easy to use. You have your templates which you created, and you can use them, and you have your tool pass immediately on your part. Now, let's say, for example, I put a face mill operation on top. I want to put another one over here on the side, but I don't have a coordinate system for that. Well, what happens is very simple. I'll take a one pass over here, face mill operation, put it on this side over here, and what's happening here, it creates a new home position automatically and puts the tool pass on that side as well. If I were to do this in, say, a different part, let me open up a different part, say an HSS part. We'll let that load for a moment. Let's say I'd like to put an HSS operation on this face over here. We have that as well. HSS, let's do linear for a second. If I want to drag HSS to the surface, just let go. Now, with HSS, the home position can be in several different areas. It can be coming from this side or on top over there. So it opens up a coordinate system, a dialog asking you to choose which coordinate system you'd like to work on. Now, I can also beforehand, if I know I'm going to be always working on only one coordinate system, I can, instead of using automatic coordinate system, I can have it at choose coordinate system. So if I have it at there, and I do the same thing over here now, since I already knows I'm working in that particular coordinate system, it'll create the operation using HSS. Now, one more thing I'd like to show you with drag and drop. What if I have an operation that I've already created, which I'd mentioned before? We'll see this on the part. And this operation I've put on top over here, inside this pocket over here. Now, I'd like to take the technology that I've used over here and put it onto this face as well. So what we can do is very simple. I may not even have a template for this. I'll just drag the operation to that surface. It'll create the home position as needed, and we'll put a tool pass over there. Want to do it again? No problem. Put it onto this face, and I can continue going on. So basically, any operation that I have, I can just drag it to a different surface, and it will automatically create a new operation. Okay, now let's continue with the demonstration. Another thing we've added, like I said, was the drag and drop for capturing geometries. Okay. Let me load another part. We'll choose this part over here. Now, let's say I'm going to drag and drop right now an operation to this surface over here, or I'll actually create an operation. Let's go and create a operation on this surface over here, and we'll choose a specific tool. And what I'd like to do afterwards, obviously calculate. And if we take a look at the part in a moment, it machined this area over here, but we have these areas over here that I'd like to machine on top of this. And I decided that the way I'm going to do this, I'm going to use a face mill operation, but just on those faces, okay? Now, before when I used the face mill operation, it chose a specific, it chose the entire part. So if I would go into face operation now, and we'll get into something new that we've done in face operation in a moment, and I create my geometry. Sometimes we have an option of not choosing the model, but choosing the faces. This we've had for a while. Now I'm going to do that. I'm going to define my faces. Let's say 1, 2, 3, those faces over there. I'll have it as separate areas. I'll accept that. I'm going to use a specific tool. Let's use a 14 millimeter end mill for this particular case. And my levels, just going to leave it exactly according to the default. And I'm going to use the one pass strategy. Okay. I can save this. Now, what's actually going to happen if I do the operation, okay, you'll see that it's going to put one pass on top of each one of these surfaces. Now, if I wanted to save that as a template, when I go save template, you'll note at the bottom it says include geometry filters. So the filter that I use as using faces instead of the entire model will be saved inside my template as well. I'm just going to save that. We'll call this webinar 1, whatever name I decide to give it. And I'm going to go out. I'm going to delete this operation. And you can see that when I use that particular template, let me just get to that template, which is over here. If I use it, drag it to this surface now, not to the part, but just to that surface, hold my control. Okay? Let go of my control. You'll see we have a tool pass for every single one of those surfaces instead of the entire part. Okay, next. We've actually made our face mill work with a new type of geometry called updated stock-based boundary. This is actually a geometry which is based on the actual updated stock. So this will guarantee full coverage of the stock face at any stage of machining. And we've also added inside our face mill operation. In our levels, we have defaults for our milling levels. We can have by top of stock, and at bottom at the depth, we can either have top of target or user defined. Let's take a look at how this works. We'll open up my next part. By the way, if you have questions, feel free to write them down in the questions area, and I'll try to get them to them at the end of the webinar. Okay, now I have an operation here that's suppressed, and I'll get to that in a moment. But let's first go into our face mill operation. You'll note that when I click on face mill, our default is stock-based boundary, and there is no geometry that has to be defined. This is automatically defined according to the stock that you have at that point. So I'm just going to go directly to tool, choose the tool I want to use. In this particular case, I'm purpose using a small end mill, 10 millimeter end mill, because I want you to see the actual tool pass. Levels, as I mentioned, we have our milling levels by top of stock or top of target. I'm going to leave it at top of stock. And the depth is 1 millimeter defined by the top of the target. Technology, I'm going to leave it at hatch for now. And I'm just going to do save and calculate. Now, if we take a look at the operation, at the tool pass itself, and we'll take a look according to the updated stock, you see that it covers the entire stock. No geometry defined. It's done automatically. Now, what does it mean by updated stock? Let me take this operation that I have over here beforehand. I'm going to unsuppress it. Now, what I did in this particular operation was I actually machined the outside of the part. So my stock on top now is different than it was before. I'm just going to calculate this operation, the face mill that I did before, and you can see that the tool pass is now completely different than what it was before. It's according to the way the stock is now. So we automatically update our tool pass according to the way the stock has been updated. Okay. Next, we've added a new option inside our chamfer recognition that allows you to ignore angled, to ignore actual chamfered edges that are already chamfered. For example, as you see in the diagram over here, if we have a chamfer at this edge, but everything else is sharp, we now know to ignore these edges. It'll also ignore any floor to wall angle, as you see over here, with this tapered wall over here. So anything less than whatever is written inside this value over here, it knows to ignore those areas. Let's take a look at how this works. I have a part specifically just for that. Okay, now as you see, this is the part I also had in the diagram itself. As you can see on the part itself, I have all of these sharp edges over here, which I want to deburr, but this already has a chamfer on it. I don't want to touch this, okay? As well as this edge over here, this is a tapered edge, and I may not want to put an edge on that. So if I were to go to my chamfer recognition and choose my geometry, we have the option of ignore floor wall angles less than 90 degrees. Now, this is obviously adjustable. I'm going to leave it at 90 degrees for now, and I'm just going to click on the part. What you'll see is as follows. It'll recognize all of the edges, but these edges over here will be ignored. These were recognized, these were ignored. This over here, this top over here was also ignored because this is less than 90 degrees. Okay, we can accept that. I'm just going to choose the chamfer tool that I want to use in this particular case. I'm going to use this one over here, 3 millimeter chamfer. My levels. We've also added, by the way, into our chamfer recognition, the option of limiting our lower level. So if I didn't want to go down to the very bottom of the part, for example, if I had a tool, if I had a chamfer mill that was not long enough to go all the way down to the bottom, I can limit the depth that I want to go to. I'm just going to leave it now at its default. In my chamfer depth, I want to have the chamfer depth at 0.2 millimeters. Technology, cutting diameter, whichever cutting diameter I want to use. Let's just do, one more thing. In my geometry, I'd also like to have 3D model protection. This will guarantee that my chamfer mill will not touch any part of any wall of the model itself. Let's do save and calculate. And if we run our simulation, and I'll use Solid Verify so we can see this very well. Slow it down just a little bit. You can see every single edge was picked up. This edge was ignored, as well as this edge. If I wanted to do that edge, this particular edge over here, but it still ignore this one over here, that I can easily change this. I'll just get rid of these surfaces and change this now to, say, 70 degrees. So anything now that I click on, if this is more than 70 degrees, it will be included. As you can see, it was chosen as well. Accept that. I'm just going to do save and calculate. And again, you can see in my simulation that the edges are being machined. And this time, it machined this edge as well. Now, by the way, remember how I talked about drag and drop? Here's a perfect case where drag and drop will almost always come in very handy. Let me delete what I've done over here. And I already have a template for chamfer recognition because I did my homework. Okay, I'm going to have it at this one over here. You take it and just drag it to the part. And you'll see my everything is being recognized at the point, and my tool path is being created without me having to go into the operation. Okay, so this is a good example of where drag and drop comes in extremely handy. Okay, next. We've added the option in our in Pocket Operation to use multi-tools in one operation. So when you're defining a Pocket Operation, if you have, let's say, a rough cut and you want to do a finish cut, you do not have to create a new operation to do that second operation. You can create it within one operation, and the results will be that you'll get all the operations for each one of those tools. And you can also switch easily to define each tool. Let's take a look exactly how this looks. And let me load a part. Multi-tool part. There we go. And what I've done here in this part, you'll see it in a moment, is that I've already created the operation. We're just going to take a look exactly how it looks inside. Okay. If I were to open up the operation, you'll see that we have what we call multi-tool. If I click over here, we have regular pocket or multi-tool. When I have multi-tool, when I go to my tool, you'll see that I can define as many tools as I want. I can have a finish, or this is going to be giving me a rough. This one's going to do a finish. And you can see that every tool pops up here on the side as well. So when I click on each one, it'll actually go to that tool. When I go to my levels, I have my levels set. Okay. Now I go to my technology. You'll see T1 will be doing a rough cut on the wall and floor offset. And my second tool, T2, when I click on it, you'll see that I'll be doing a finish on the wall and floor. Taking a look at the simulation over here, You can see the first operation, which was actually the first tool. And then I have my second operation for the next tool, doing the finish on the part itself. So in one operation of Pocket, I can create several operations. Okay. Now, we've made improvements also in our part synchronization when we use the geometry of SmartFace. Okay, so where it is extremely helpful, elements that are added or deleted from a shape of the face are now recognized, and bosses that are added or deleted from faces are also recognized. We've always had geometries. The synchronization was based on chains, and if the chain's dimension was changed, you had no problem doing a synchronization. But if you added a boss to the part, that's something that did not exist. Now that we have a geometry called SmartFace, you recognize the fact that you chose the geometry from SmartFace, and anything that is changed on that face will now be synchronized as well. Let's take a look at a good demonstration of this function. Now, in this particular part, I'm just going to create a simple pocket operation. So let me take my drag and drop, my pocket operation. I'll use this one. I'll use this one over here. You drag it to the surface, and we have a pocket operation over here. Okay. Note when I use this, we use the surface. So this is called a smart face geometry. If I look into the operation itself and go to edit, we have smart face. When we have a geometry created with smart face, doing any changes on the part will now be recognized. Let's take a look. What I'm going to do now is I'm going to open the actual part. I'm going to make some changes to it. I'm going to add something to this part. Say I'm going to add this boss over here and this area over here. Let me just save this. When I go back to the part, you see the part has been updated. Let's just synchronize the part and just calculate. You'll see that the tool pass, calculate. Didn't synchronize it correctly. Let's just do it the other way around. Click on the smart face. We have our tool pass. If I go back and open the part, okay, and I'm going to get rid of what I did over here. Save that. I'm just going to synchronize and calculate. And you can see that my tool pass will automatically change without any problem over here as well. And it works the other way around as well. Okay. Now, one more thing I'd like to go into for a moment. We talked about let's talk about our general. We have stock that can be created, a stock model can be created from our stock. Before you were able to create just a sketch, 3D sketch, but you can now also create a stock model from the actual stock itself. Also, we have CAM menu customization. CAM menu customization It's very simple. In the operations, as you see over here, we have this operation over here. If I right click on it, we have a pretty long menu. Not only that, but if I go into my add operations, right now, it's pretty short. It's shorter than it usually is. Why? Because I customized it. What do I mean by customizing it? I can have operations that I don't normally have in here. I can put them back, and you can see I have a complete list if I wanted it. So now when I right click, you can see that this list is longer. If I'm using, if I don't have all of these options, I can, again, like I said, customize and take out whatever I don't need to make it a little easier to view. Now let's get to our last point inside the webinar itself. Now, I know that in our last webinar, we had talked about iMachining, but there are a few points I'd like to bring up also. With the iMachining feature recognition, what I'd like to bring up are some things with the geometry definition modes. And I'd like to concentrate in particular on two of them. One called outside feature recognition, and one is the feature recognition by faces. Now, the outside feature recognition, excuse me for a moment, will automatically recognize, without needing to choose a geometry, the outside shape of the part, and we'll see also the boundaries of the stock. So it'll automatically create an operation based on that. Let's take a look at how this works. In particular, using a part that's a little bit different. Let's go to this part over here. And the reason why I'm going to use this part is you'll note the following. When I create, if I want to create your geometry, your old geometry around the outside of the part, this is relatively difficult to create because you have a chain that goes over here but doesn't go all the way around. So you have to start going up and all over the place in order to create your geometry. But with iMachining now, we have the option of what we call outside feature recognition. I don't have to create a geometry in this particular case. It'll automatically recognize the stock from the outside and the boundary of the part. I'm just going to choose a tool for this. And let's say I'm going to use a 14mm end mill. You can see that the stock is now visible, showing you exactly what's going to be removed from the part. And I'm just going to do calculate. And you can see that the outside is going to be machined without the need of picking that geometry. Run my simulation. You can see that as well. Solid verify. Run it quickly. You can see it's machined exactly where it needs to be machined up until. Now, let's go out of here. And I'd like to machine some of these surfaces over here. So I'm going to go into iMachining again. And this time I'm going to use the very first option, which is feature recognition faces. All I have to do is click on the faces that I want to machine, and you can see it appears here. Click on this face, and you'll note that's not even on the same level. This face, let's just leave it at that for a moment. Choose my end mill. I'll use that 14mm end mill again. You can see exactly what's going to be taken off, including their upper and lower levels for each pocket, each one of those surfaces. I'm going to save and calculate, and you can see the tool path that's created on it. You can see it machines exactly to those pockets. Now, what I'm going to do is one more thing. Remember this original operation where I machined the outside? I'm going to right click on that for a moment. I'm going to suppress it as if I didn't do any outside machining. So if I were to calculate now this operation over here, you'll see we'll get a different toolpath. A toolpath now is according to the actual stock that's outside. In other words, even though the faces were up until here, it sees that the stock now is up until this point over here, and we can do this updated stock. And it's going to machine up until the actual stock itself. And of course, all of these operations work with drag and drop templates. Okay. That is it for the webinar. I see I have one question. And that is, can SolidCAM customize the menu by check out the gray options? Well, the only way we can do it right now is just, like I said, going to customize. But checking out this, it does not work that way. We have a regular customization just by the menu itself. By the way, this is also true inside SolidWorks itself. You go into any of these menus, you can customize it as well by that. Over here, customize that as well. So it works the exact same way as in SolidWorks. Okay, multi-depth drill, can we save templates with levels? You can save it, but it will not work with drag and drop, because with drag and drop, with drag and drop, we don't know for that particular part that you're going to, what the actual depth is going to be. You can definitely save it as a template, but it won't work with drag and drop. Okay, like I said in the very beginning of the webinar, I've recorded this webinar, and the webinar will be available on our website, www.solidcam.com, by just going into our tab of webinars to webinar recordings. This will be available there. Probably by tomorrow morning, you should be able to see it over there as well. I'd like to thank again everyone for joining our webinar. It was a pleasure seeing all of you inside, and we'll see you again in our next webinar. Take care and have a fantastic weekend.